right, hi everyone. Let's go ahead and get started. So 3 minutes on the clock. Do you speak any languages besides English? If so, which ones? Go and write your answer in the chat. How do you know what the index of a radical is? We're going to share that out loud. And then how do you simplify a radical? We're going to share that out loud as well. Got English. All right, also make sure to turn on your video if you haven't turned on your video. Ooh, Hannah, I didn't know that you spoke some Chinese. Thirty more seconds, and then we'll get started. All right. How do you know what the index is? How do you know what the index of a radical is? What do you have for me, Hannah?
I don't know. I really don't know this one.
Were you here yesterday?
No.
Okay, that would explain it. All right. How do you know what the index is? Liana, what do you have for me?
I wasn't here yesterday. I don't
You
know.
weren't here yesterday either. All right, Sandra, how do you know what the index is?
Isn't it the root of a real number?
Yep, so it's that little number that's next to the radical. Thanks for sharing. Liana and Hannah, where were you yesterday?
I had an appointment.
Okay.
Same.
What
Yeah.
kind you guys had an appointment?
Yeah, I was at the School of Dentistry.
Okay. Make sure that you all watch the videos just so that you can stay up to date even if you do miss. It is important. Learn stuff that is new every day. All right, let's go ahead and get started with today's notes then. Before we do that, does anyone have any questions from last night's homework? Okay. Let's go ahead and get started then. So the first thing we're going to do is fill in our notes. So we've got our notes. Actually, we have to do good things. I forgot good things. Um, let's start with Liana. What's your good thing?
I got a new phone yesterday,
Cool. Exciting. What kind of phone did you get?
an XR.
Awesome. Very cool. Thanks for sharing. Hannah, what's your good thing?
This is minor, but I changed my screensaver on my phone, so it's like really peaceful looking. That's a good thing.
I like that. Thanks for sharing. Sandra, what's your good thing? I think you're still muted.
I don't have one.
Nothing. What's the best thing that happened today?
Nothing. I just have a lot of homework today. So that's not it.
All right, fair enough. My good thing was I got to go outside and do some yoga yesterday, so it was nice to be outdoors. Ethan, where were you? Why are you late?
I was talking to my sister. And I got distracted.
Okay, make sure that you log in on time because we only got like 10 people in this class, so we notice if we're missing people or if they're late. All right, let's go ahead and get started. If you got a chance to print out the notes, it's 6.2. We're multiplying and dividing radicals. We're going to go ahead and popcorn the steps out loud while you copy them if you haven't printed them out. So let's start with Liana. Could you read step number 1 for me?
Check if both radicals have the same index.
Great. Then Hannah, read number 2.
Factor each radical.
Perfect. Sandra, can you read number 3 for me?
Group them together under one radical.
Perfect. Ethan, can you read number 4?
Circle groups based on index.
Great. And then Liana, can you read number 5?
Take out the number or variable from each circle group. Everything that is uncircled remains.
Great. And then number 6, go ahead and read that for me, Hannah.
Simplify possible.
Okay, perfect. So for those of you that weren't here yesterday, this is building off of what we did yesterday. So I'm going to try to break it down to try to go over what we did yesterday as well, because some of these steps might be confusing for you if you don't know what we were talking about yesterday. So first step, check if both radicals have the same index. So you find the index by looking at this little crevice of the radical sign. Since this doesn't have a number inside the crevices, we can assume that the index is 2, which means that you're taking the square root of each. So the index is 2. They both have the same index. You can go on to the second step. Factor each radical. So we're going to start with the 4, and you want to find 2 numbers that would multiply to give you 4. So that would be 2 and 2. Your goal is to break it down to prime numbers. So you want to make sure that you break it down into numbers that are prime, which means that they can't be factored into anything besides 1 in itself. So 2 is a prime number because the only 2 numbers that would multiply to give you 2 are 1 and 2. 4 is not a prime number because you can break it up into 2 times 2. So if you can't break it up any further, that's when you have a prime number. So 2 is a prime number, so I'm going to circle that to remind myself that I'm done with that little factor tree. This is what we call a factor tree. Then you're going to rewrite the 4 as 2 times 2. You're going to do the same thing with 9. So I will go ahead and call on someone. Sandra, what are 2 numbers that would multiply to give me 9?
3 times 3.
3 times 3. Is 3 a prime number? What do you think, Liana?
Yeah.
Yeah, because you can't break it down any further, right? The only things that go into 3 is 3 and 1. So those are prime numbers. So we can go ahead and circle that. So we can rewrite this as 3 times 3. Next thing, we have to group all of these together underneath one radical. So I have 2 separate radicals, but I want to group them together underneath one radical. Make sure you list out each factor from least to greatest. So you have the 2's first, and then the 3's. And then we circle groups based on the index. So in this case, we found out that the index was 2. So I want to circle pairs. So I have a pair of 2, so those can get circled. And then I have a pair of 3, so those can get circled. So it all depends on what your n value is. In this case, it's 2, so we're circling pairs. If it was 3, we'd have to circle groups of 3. If it was 4, we'd circle groups of 4. You can take out one term from each circle. So I can take out a 2, and I can take out a 3, and those get multiplied together, and nothing was left uncircled. So I actually have nothing left under the radical. So the radical will disappear, and you're just left with 2 times 3, which is 6. Questions on number 1? All right, let's look at number 2. 5 squared of 6 times 2 squared of 3. First step, do I have the same index? Do both of those radicals have the same index? What do you think, Ethan?
No.
Why?
No. Is it the first one? Oh, wait, I was leading that wrong. That's not a 5. Yes, they do. Because
Yes.
they both have nothing.
Yeah, and the
Which is
index,
a 2.
what, sorry, Ethan?
Hmm?
What did you say the index was?
Oh, I said it was 2.
Sorry, I didn't hear that part. N equals 2. All right, next thing, you got to factor each radical. So factor whatever's under the radical. The first number we're going to factor is 6. What are 2 numbers that would multiply to give you 6? Hannah?
2 and 3.
2 and 3. And are those prime numbers, Hannah?
Yes.
So we're going to circle both of them. We're finished with that. So we're going to rewrite 6 as 2 times 3. And then we got to factor out the 3. Is 3 factorable? Is 3 factorable? What do you think, Sandra?
No.
No, because it's prime. So
You can only do
with it, you just have to keep it as square root of 3. All right, now we're going to group everything together underneath one radical. So this one's a little bit different because we've got the 5 and the 2 on the outside. So they're just going to join forces together on the outside. And then you're going to group everything inside of the radical together. So you've got the 2, the 3, and the 3. All right, now we have to go ahead and circle groups based on the index. So my index, Ethan said, was 2. So I'm going to circle pairs. I can't circle the 2 because it doesn't have a pair, but I can circle the 3's. So we've got 5 times 2 times 3, and then the square root of 2 stays underneath the radical. Anything that's uncircled stays underneath the radical. And now we just simplify the outside. So 5 times 2 is 10, 10 times 3 is 30, square root of 2. Any questions so far? All right, let's look at number 3, cubed root of 4 times cubed root of 16. Do I have the same index? Do I have the same index? What do you think, Liana?
When you say the index, I don't know.
You're looking at the number inside of this radical. So do you see how there's a 3 here and a 3 here?
Yeah.
So do they have the same index?
What?
Do they have the same index?
Yeah.
Yeah, and what is that index?
3.
3. So the only time it's a little confusing is an example like 1 and 2 where you didn't see a number. And if you don't see a number, you can assume the index. Does that make sense, Liana?
Yeah.
Okay. All right, so now we have to factor each radical. So we're going to factor out 4. What are 2 down multiplied by 4? What do you think, Hannah?
2.
2 times 2 and Hannah, are those prime?
Yes.
So you can stop there. So you're going to rewrite this as the cubed root of 2 times 2. Now let's do 16. What are 2 numbers that would multiply to give me 16, Ethan?
4 and 4.
4 and 4, and Ethan, are those prime?
No, they are not.
So what can you do to break up the 4s further?
Divide them both into 2.
So we got 2 times 2 and 2 times 2. So you have 1, 2, 3, 4 2s. Going to be the cubed root of 2 times 2 times 2 times 2. All right, now that you've got them factored, you're going to put them all together underneath one radical. So you have 6 2s total. And our n is 3, so we're going to circle groups of 3. So I have a group of 3 2s, another group of 3 2s. So you can take out a 2 times 2, which is equal to 4. So 4 goes there. Nothing is left under the radical, so the radical will disappear.
Wait, how did you get this to be 2 2s?
How did I know to circle the?
No, how did you get it to only be 2 2s? Like at the end of the night, 2 times 2 before that. How did you get it to be 2?
Can you type it in the chat instead, because you're breaking up? And I'll answer your question.
Okay.
How did I get it to be 2 2s? Okay, because I'm circling groups of 3 because my index was 3. So I had one group of 3 2s, so that's how I took out the first 2. And then I had a second group of 3 2s, that's how I took out the second one. So 2 times 2 ends up being 4. Does that answer your question? Okay, cool. All right, the last one is a little bit different. Root of 8x times the 4th root of 4x to the 5th. So this one's a little bit different because we've got numbers and we've got variables. So the first thing we're going to do is just check and see, do we have the same index? So do we have the same index, Sandra?
Yeah.
Yes, and what is that index?
4.
4. Good. All right, so now we have to break it up. So 8 breaks up into 2 times 4. 2 is a prime number. 4 breaks up further into 2 times 2, and those are prime numbers. So I can rewrite this as 2 times 2 times 2 times x. And then we've got 4. 4 breaks up into this 2 times 2. So I can rewrite that second one as the 4th root of 2 times x times x times x times x times x. I should have 5 x's. All right, so in this first, now we're gonna have to combine these together. So I want all the 2's to go in the front, all the x's to go at the end. So I've got 1, 2, 3, 4, 5 2's. And I've got 6 x's. All right, we're gonna go ahead and circle groups of 4 this time because our n is 4. So I've got these 4 2's. And then I've got these 4 x's. All right, so I can take out a 2 and I can take out an x, but I still have this 2 uncircled, so that has to stay underneath the radical. And then I have the 2 x's, so x squared is still underneath the radical. Questions on number 4? All right, the last thing we're going to talk about is dividing radicals. So dividing radicals is kind of similar to multiplying radicals. The first thing we're going to talk about is the quotient rule. So when you divide coefficients, I can't speak today. When we divide radicals, the first thing we do is divide coefficients, then we use the quotient rule. So the quotient rule tells us that if we have 2 separate radicals, so one in the numerator and one in the denominator, we can actually combine them together under one fraction. So if they have the same index, you can put them underneath one radical and then just write it as a fraction. And then we just simplify the resulting radical. And this is vice versa too. If you have a fraction, you can split it up into 2 separate radicals. So you can go either way for those. All right, let's look at number 5. We've got 48 over 16, 48 over 16. First thing you want to do is check and see, can you simplify what's inside of the radical? So can you simplify 48 over 16? 48 divided by 16 is 3. So yes, you can simplify that. And then 3 is a prime number, so you can't actually do anything further. It's just the square root of 3. Questions on that?
Where did you get 3 from?
Because 48 divided by 16 is 3. So if you can simplify it, you simplify it first. And that's it. All right, let's look at number 6. We've got 40 over 27. Unfortunately, that can't be simplified any further. There's no number that goes into 40 and that goes into 27. So the next step we have to do is use the quotient rule to split this up into 2 fractions. So the cubed root of 40 over the cubed root of 27. And then we're going to split it up. So take the 40, and we're going to find 2 numbers that would multiply to give me 40. What are 2 numbers that would multiply to give me 40? Ethan?
2 and 20.
2 and 20 will work. 2 is a prime number, so we'll circle that. 20 can be split up into 2 times 10. Circle the 2. 10 can be split up into 2 times 5. So we can rewrite this as 2 times 2 times 2 times 5. And then we've got 27. What are 2 numbers that would multiply to give me 27? Hannah.
9 and 3.
9 and 3. And then 3 is a prime number, but we can split up 9 into 3 times 3. So we've got the cubed root of 3 times 3 times 3. What's our index going to be for this problem? What's our index going to be? What do you think, Liana? Liana, where'd you go? We lost her. Sandra, what's our index? 3. So we're going to circle groups of 3. So you've got the 3 2's in the numerator, so you can take out a 2. The 5 is uncircled, so it has to stay underneath the radical. And then in the denominator, you have the 3 3's again, so we're going to circle that and take out a 3. And double check, make sure you can't simplify any further. There's nothing that goes into 2 and into 3, so that's your final answer. Questions on that? All right, let's try the last one together, and then you guys are going to try 8 on your own. So let's do number 7, the cubed root of 7x to the 5th over 64y to the 6th. First thing, check and see, can you simplify 7 over 64? So can we simplify 7 over 64? What do you think, Hannah?
Yes.
Is there a number that goes into 7 and into 64?
Never mind. No, that's 8. No. So no.
So unfortunately we can't do anything, so we just have to split it up into 2 separate radicals. 7 is already a prime number, so we don't have to do a factor tree for that. It's just going to be 7 times x times x times x times x times x over we've got the cubed root of, we have to simplify 64. So 2 numbers that would multiply to give me 64. I'm going to go with 8 times 8, but you can choose any 2 you want. 8 splits up into 2 times 4. 2 is a prime number. 4 splits up into 2 times 2. And you're going to do the same with the other 8. So in the end, you have 1, 2, 3, 4, 5, 6 2's. And I'm sorry, I ran out of space. I'm going to write it really tinily. So 6 2's and then 6 y's. What's my index, Ethan?
4.
What's the little number we see right here?
Oh wait, we're on 7. My bad. 3.
3. So we're going to circle groups of 3. So we've got these 3 x's at the top, so that gets to get grouped together. So you can take out an x, and you're left with a 7 and an x squared in the numerator. Over, in the denominator, you got these 3 2's, these 3 2's, these 3 y's, and these 3 y's. So you can take out a 2, a y, and nothing is left uncircled. So all you have is x, cube root of 7x squared over 2 times 2 is 4, y times y is y squared. Questions on that? All right, I'm gonna have you guys try 8 on your own. So I'll give you all 4 minutes to try it out. And then I'll call on someone to go over it. You can talk to each other. You can talk to me. Just think of us as like a little mini breakout room. So we're gonna try number 8. I'll give you all 4 minutes. And then feel free to unmute yourself so you can talk to each other or talk to me. Three more minutes. One more minute. All right. Do I have a volunteer that wants to share their answer? Or I'll volunteer you. Either one will work. All right, Hannah, what do you have for me?
Knew she was gonna pick it. All right. I have the radical of 2W over 3.
Okay, almost, but you forgot to take out the 2. So you have to take out a 2 from the numerator, right? Because you have a group of 2. You have the
Okay.
2 over 3. Does that make sense?
Mhm.
Ethan, Sandra, do y'all have any questions? Did you get it right? Okay, does anyone need this before I change the screen? All right, we're not going to do the back of these notes. We're going to save that for tomorrow. So your homework tonight is the worksheet that's on Canvas that I assigned yesterday. So you need to take a picture of your completed work and upload it to Canvas by tonight at 11:59. And then you have a Big Ideas Math assignment that's going to be due tomorrow, Thursday at 11:59, because we still have to finish the second half of the notes, which we'll do tomorrow. Questions? All right, that's all I got for you. So feel free to log off. I'll stick around till 3:15 if you want to get started on your assignments or if you have any questions.